this session is about understanding monads with JavaScript. Initially we'll just look at some JavaScript code and try to get a feel for what monads are, and then later on we'll look at some use cases for them in C#. That's me, Ashik, that's my website, that's my email, that's my Twitter. Right, so what are monads? Well, they're geeky stuff. They're really nerdy, geeky stuff. You know, it's like maths and all that type of things. And if you see the Wikipedia article on monads from category theory, you'll see what I mean. So it starts there, and it's a very nice introduction, but then it turns out to be something like this. And that's not that simple to understand anymore. Perhaps if you study category theory, you can make heads or tails of that. I have difficulty in doing so. Anyway, back to the slides. And if you actually understand all of that, you probably wear some very thick glasses for all your hours of reading. But actually, the concept of monads are not that hard, as we shall see. It's originated in category theory, sometime in the 40s or 50s or something. And it was first applied to programming in Haskell. And Haskell is a very sweet, beautiful, elegant functional language. If you haven't tried out Haskell, I would highly recommend playing with it whenever you get the chance. The concept at heart of monads is actually quite simple, and it's immensely useful in modern day stuff. For example, dependency injection, aspect orientation, and that sort of thing can be done quite nicely using monads, and we'll see some demos of that later. Monads can be used for a lot of other things, not just that. For example, in Haskell being a purely functional language, it does not allow state modifications. But in order to do any real operations, if you will, you need to have side effects. And using monads, Haskell can let you do maintain the purity of a purely functional language while allowing certain side effects to take place. We won't go into Haskell today, but we will try to get a concept of these things in terms of JavaScript and C#. The core idea of monads is that they are computation expressions, or say suspended computations, and you can compose them to make more suspended computations. Now, none of these compositions would actually execute anything until the compose function is actually triggered. And we'll see examples of that as well. And since I'm going on and on about examples, let's go on to some coding. Okay, so what I've got is a very simple script. It's inside of the index page, nothing much to see. I've included the script in the header. But here, what I'll do is I'll write two functions. I'll call the first one bind, and I'll call the second one unit. What bind would do is it will take something, and it will take a function. And from that something, what I'll do is if ma and not is ma. I'll assume that ma in this case is a string. We'll get to the types later. Then I'll return func with parseInt of ma and the radix is 10. Otherwise, I will return a string that says not a number. So that's our bind operation. And the second thing, the thing we call unit, what that will do is take in something and simply call toString on it. Okay. So we have two functions called bind and unit, and what they are essentially doing is that unit is going to take one type, and we will call that type a lower type. In this example, it could be some number, like 1, 2, 3, 4 or something, and it will raise it to an upper type. And by that upper type, in this example, obviously it's a string. It could be anything really, any type that has a higher level of abstraction, if you will. In our case, we are saying that our lower type is a int, and the higher type is a string. So what bind does is it takes as the first parameter, it takes an upper type, and as the second parameter, it takes a continuation function that accepts a lower type. And in the bind, we're checking if the upper type is null, the first parameter is null, or if it's not a number. If it satisfies both conditions, then we simply pass the int, i.e. we extract the lower type from the upper type, and then we pass it to the continuation function. If the condition is not met, then we simply return not a number. Notice that this is also the upper type. Unit is considerably simpler. All it does is it takes a lower type and it returns an upper type. Right. So what do we get from this? Well, with this we can do something that looks like this, and I'm violating some JavaScript things like using the single var pattern just for convenience's sake here. But you can call a function process, if you will, or other results. That sounds better. And here what we can do is we can call bind and pass in 2. And as a second function, second parameter, something that, that returns bind that takes in, say, 3, and that in turn does another bind to, say, 10, okay, and that finally returns units of A plus B plus C. Okay, actually let's go another level. Let's say bind of 50, bind 50 to function D, and then we go unit A plus B plus C plus D. Okay, so what have we got from this? Well, if we do a console.log on the result now, let's actually execute that. Ooh, sorry, is not defined. Typo. Okay, you can see I've got 65, which is the sum of 50, 10, 3, and 2. Now, what have I got out of this? If I did not do this, what I'd have to do is I'd have to pass 2, pass 3, pass 10, and pass 50. I'd have a lot of boilerplate code in the location where I am processing that code, instead of having that sort of parsing thing handled over here inside of the bind. And I can look at this, and apart from the function bind, function bound, function return bind, that thing, it is fairly simplistic, as in it says, yeah, you're binding 2, 3, 10, and 50, and you are getting A, B, C, and D. Now, if that were the only use, then it possibly wouldn't be that useful. But now, what I can do is I can say X, Y, and Z. Say, instead of 60, I've got X, Y, and Z. If I execute that, what I'll get is not a number. So what I can do with this is I'm essentially creating a pipeline-like thing where something is entering in one end and continuing till it gets to the other end. And if it does get to that other end, then I finally call that function. If it doesn't get to that other end, at any point in time over here inside the bind function, I'm just rejecting it. I'm not continuing the flow. Like I'm saying, if this condition isn't met, I will not continue the chain. I will simply return then and there. That can be quite useful. What can we do next? Right, so where does monads come into this? This is essentially a monad. A monad will have a bind operation and a unit operation. The bind operation will take the upper type and a continuation function. It will extract the lower type from the upper type and call the continuation function. What the unit will do is it will take the lower type and simply raise it to the upper type. And a chain like this is typically called a monadic chain. In Haskell, you wouldn't call this a function a unit, you would call it a result. Oh, sorry, you would call it return. Many people call it result when they're working in JavaScript, but anyway, right. So that's, say, one use case of it. This can be useful in some other ways as well. For example, let's say we have add function that simply takes two variables, a and b, and returns a plus b. Okay, not very interesting. Say we have another function that takes c and d, well, doesn't need to be c and d, it can be a and b, and returns a minus b. Okay. Now, these functions, they work on the lower data type, i.e. they take in numbers and return a number. Say we want to do some calculations based on an upper type. Let's say we want to do some calculations based on the upper type without actually having to deal with all the messy conversions where we do the computation. In that case, what we can do is we can declare a function add2, and what that will be is that it will be a function that takes an upper type and another upper type, and it turns bind that function of a, bind and b, function taking b, and that can actually call out to the add method using the two lower types. Okay, and now what I can do is, let's get rid of that one. Let's say we can do add2, and this time instead of dealing with the lower type, we can simply do add2 and add3. Sorry, add2 of 2 and 3. If we execute that, you can see that I've actually got the result 5, which is a string again. So at this point, I can compute in terms of the upper type, string, or an object, or something else, while the underlying implementation possibly could look at a representation of that upper type, like say a passed int, or if it were dealing with in terms of if it were dealing with objects, some property of that object, and do that sort of computation based on the computation available for the lower data type, like say add. Okay, but then this is also a bit of code, and at the same time you can see the structure for this is always going to be the same, regardless of which binary operation I have, whether it's add or sub. The only place it's mentioned is over here. So what we can do is we can define a function called lift, which will taking a function that's a binary operation on the lower type, and then it can return a new function that takes in 2 of the upper types, and it then does the same thing, as in binds the upper type, function lower, and that returns the bind of the second upper type, second lower, and this returns a unit of calling the function that's passed in. Instead of and, we are now instead of add specifically, we're simply calling out the function that was passed in to lift. And now what do we get from this? What we get is, say, add 3, or rather add version 3, I should say. It doesn't take 3 parameters. And I can say add 3 is now a lifted version of add. Similarly, sub 3 is a lifted version of sub. And no matter which operation I have that works on the lower data type that takes 2 parameters of that type and returns that type, I can simply use lift to create a function that actually takes 2 of the upper data types rather than the lower data types. And then I can do something like this. I can say var, well, I think I've already used result up top. Anyway, I'll say res, add 10 after subtracting 50, well, after subtracting 5 from 50. And then if I log the result and execute that code, oops, console, ooh, that's a big number, that's 1045. I'll keep going to Visual Studio. Right, let's see. What have I done here? Sub does a minus b. So that's 55. Subtract 5 from 50. Take the results. 45. Oh joy. Yes. So probably shouldn't be doing add. If I do it the other way around, that should be safe. Yeah. So I run into. I talked about this exact thing this morning. Well, this afternoon, about the JavaScript WTF thing, and that was an example, right? So if I do add, if I do it the other way around, that should be okay. Let's say I want to add 10 to that and minus 55. Does that make sense? I'm first minus 55. Why would it be minus 55? God knows. Anyway, there's some computation issues involved, probably some JavaScript. But essentially, what I can do is I can compose some of these operations in terms of the upper data type. If I'd been using objects for that, that would probably not result in these errors. Probably some sort of weird string issue. Yeah, what it's doing is add 10 and... Oh, sorry, my bad. This should be add 2, and that should add 3, and that should be sub 3. Right, that's it. And that works as expected, 35. There we go. Yeah, when you've gone through the trouble of actually lifting it to the upper data types, it would help if you don't use the lower data type functions rather than use the upper ones. Okay, so and this lift operation, that's also done through a monad, as you can see. Right, in terms of JavaScript, where would you use this? If you find places where you can use this, fine, go ahead and use it. But this is kind of just demonstrating what monads are and how it can be used to compose and deal with things at a higher level of abstraction. So, for example, in our chain over here, we didn't have to worry that this was not a number. This was taken care of during the composition stage, and if we called the result of this computation, we wouldn't get an exception or anything else, while this is relatively close to the real function that's being taken care of, apart from all the boilerplate and plumbing code. Okay, right, so that's the JavaScript bit. How do we use this in C#? And in terms of C#, it's actually quite nice and useful as well. C# does monads slightly differently. It's not exactly a combination of bind and units. They kind of combine it to do the same thing. But the core idea, as I mentioned previously, is that it's not an out-and-out computation. Whatever you do, it doesn't trigger an operation. What it does is the composition creates a new function that is ready to be triggered when you trigger it. And when you trigger it, it then goes off and computes all the values and stuff. Okay, so this is one example where we have an array of items, and then we do items.select, and in the select, we're passing in a lambda that does console.writeLine and says selecting that and returns x. Okay, now no matter how many times we run this, that select isn't actually running. All that select is doing is it's creating a computation that, when it queries, will call out to this thing. So this select isn't actually pulling any items from there. But if we make one little change, and we do dot to array or to list or something, then what we'll see is that that is now being executed. And you can see it says select 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And we could do something like var foo equals, and we could then do var bar equals foo dot order by descending, and even then we wouldn't actually be triggering anything because we're not accessing anything. We're just creating computations at this point. But then the moment we do bar.toArray, when we actually need that information, that's when the operation is executed. This is kind of similar to where we defined an upper version of add over here, or via lift. We defined another computation here, but we only actually executed what's inside when we called out to those functions, applying the parameters to the function. Okay, now in .NET there's obviously many areas where this is applied. If you think of LINQ, pretty much all of LINQ has some notion of computation expressions, iQueryable, iEnumerable, and you can do all those LINQ queries that don't actually execute until you do something like a count, or a toArray, or a toList, or a toDictionary, when you actually want to do the actual computation that's behind the suspended computation. That could be in the form of a database query, and that's why you can do, you can split a LINQ query into 5 or 6 different statements, but until you actually hit a for each loop, or a toArray, or a toList, no database query actually fires. Okay, so that's how they do it in C#. The C# compiler takes care of it for you. But how can you use this in your application, and what benefit will that give you? Well, to do that, we'll have a brief look at some classes. This is a simplified message bus. It's not really a message bus, bus per se. All it does is it maintains a dictionary of type to action. It lets you allow action of T handlers to be registered against a particular type, and when it receives a handle, a command of a type, it looks up the handler and executes that handler. This simplistic bus doesn't have error checking in it. It doesn't have advanced features like polymorphic dispatch or anything else. Or even event publishing. This is like one type, one handler. But still, it will serve our demo purposes. I'm sure you're aware of the fact that action of T simply represents a function that takes in a single parameter of type T. That's the only thing that we're using here. We have a class called SomeHandler. All that has is a handle of SomeMessage. SomeMessage isn't really anything interesting, it's just an empty class. And the handle of SomeMessage, what that does, it says handling the message, setting the foreground color so that it looks pretty. Okay, so to start off with, we can actually run this. And the code for that, what that's doing is it's saying bus equals new message bus, handler equals new SomeHandler, bus.register handler of SomeMessage, handler.handle. And what you'd do, where you'd put this code, is where you hook up your dependency injection container, or at the very top level of your application. Okay, your application code will have no idea of any of this except the bus. It wouldn't know what handlers are registered where or anything else. Your application code just knows that there's a bus. And when it needs to carry out some operation, like say SomeMessage in this case, it will call bus.handle. So this is the simplistic application code that you'll have. If you're doing MVC, your controller would have access to the bus instance, and it will do bus.handle, new SomeMessage. It doesn't care if it's actually going to a handler, if it's not going to a handler, if it's going to some handler, if it's going to some other handler. All of that is configured at the very top level of your application, independent of your application code, if you will. Now, if you execute that, you can see that it just says handling the message. That's not very interesting. Let's make it slightly more interesting. Let's say we have another handler that this time takes in a dependency. So this is the same thing, just like before, but through its constructor, it's taking in it's taking in an instance of a class that implements iProvideSomeMessage. iProvideSomeMessage is a very simple interface that has a single method called getMessage, right? And in its handle, what it does is it simply says handling message with, and it spits out the message that the message provider gives it. Okay. And in this case, we have a hello provider that says getMessage. So how would we inject this dependency? Well, over here, that's actually quite simple. That's what run 3 is doing. Right, so this is the code for run 3. It's quite similar to the previous one, only here what we're doing is var bus equals new message bus, var SomeMessage provider equals new hello provider, var handler equals new SomeHandler, passing in the SomeMessage provider, and then we do bus.register handler, SomeMessage, handler.handle. Now, notice your application code that was previously there is still exactly the same, although we have completely switched which handler is actually handling that message. Previously it was SomeHandler, now it's some other handler, and we're also injecting a dependency, that's the iMessage provider, and we're doing it at the very top level of the application without having to touch any of the application code. And if we run this, sure enough, you can see it says handling the message with hello. So it is using that dependency in that case. Right. We can actually take this a bit further. We can take this a bit further and use it for aspect orientation as well. We used it for dependency injection over here, but let's say we are now concerned with that particular handler, and every time that comes in, we A, first want to log it using some logging mechanism, and B, we want to do some security checks and actually execute the code inside of the handler only if the security check passes. Now, the typical approach to this could be something like this. You would come to your SomeHandler, and you would probably take in some, well, I'll comment it out because I don't have the interfaces ready. And you could say security service, security, and logging, not logging, logging service log, and you put them in the instance variables, and then you modify your handle code to actually do that. The problem with that is that if you have even a number of handlers, you'd have to go into each and every one of them where you want to add that new feature, and you'd have to modify that code. Not only that, if you think about testing, previously the core of this was already tested and it was deployed. Your security service might have, I don't know, 2, 3, 4 different branches. Your logging service is likely to have just one, maybe two, based on the config flag. If you were to get proper confidence writing tests for the new modified class, you'd have to write a number of tests for some handler checking on various things for security and logging and all of the branches that they contain. So for this some handler2 class, not only are you modifying the code, you're also having to add lots and lots of tests. There is a better way of doing that, and we can do that with suspended computations or computation expressions. Over here, what we're doing is we're newing up a bus and some provider just as before, and then we have our handler. After that, we simply do bus.registerHandler, and we call wrap with logger. Okay. And we call wrap with security. And then we pass in handler.handle. Okay. So what is wrap with logger doing? Wrap with logger is taking in an inner action, i.e. the continuation, in this case, and then it's returning a new logging executor .handle. Now notice that there's no brackets after this, so it's not actually handling the command, or there isn't a command to be handled at this stage. What it's returning is it's returning an action of t. So it's kind of like intercepting any calls to the handle, the inner handler, the inner action of t, and it's wrapping the logging executor around it. And if you go and see what the logging executor looks like, it's this. It takes an action of t as the next, stores that action of t, and then when we call handle, what it does is it first logs it, and then it simply calls the continuation that was passed to it. So next passes command to the next that it received through the constructor. Wrap with security works in exactly the same way. You've got your action of t inner, it passes it to the constructor of security enabled executor. If you needed to pass something like, whether it's an admin or not, you could pass that to it. Or if you needed some other keys, you could pass it at that level, constructor inject it. But again, we're taking in a function, i.e. an action of t, and we're returning an action of t, and we're adding something around it. So it's like a wrapper around whatever is passed through the inner. And when we're doing bus.registerHandler, it's first taking this handler.handle, wrapping it with the security handler, and then wrapping it with the logging handler. If we want to take a look at the security enabled handler, that's doing exactly it's doing similar things as the logging executor, in that it does some security check, which for convenience's sake, I've just said done security check, setting the color to green, and then it calls next.command, or rather, it calls next, passing in the command. With this, you can create pipelines, and the configuration of which aspects are applied to which section of your application, all of that still resides in your composition roots. If you look at your application code, that's still simply bus.handle. So at the very top level, you can tweak dependencies, you can play with cross-functional stuff like logging and security and possibly even caching, and not have to worry about modifying any existing application code in order to add those cross-functional features. And if you kind of look at it, this is similar to what the bind function is actually doing. The bind function binds an upper data type to a continuation function by extracting the lower data type. We're not really worried about the data types in here. We're enforcing the input to be action of t and the output to be action of t. But the composition chain that we're creating means that at any point in the composition chain, we could not call next. So, example, we could say that, comment it out again, if http context dot current dot user dot is in role admin equals to false, well, or rather, let's say if that's true, only then would we call next, passing in the command. Otherwise, we would simply break the chain at that point, and possibly throw an exception or not throw an exception, and simply not return anything, log the fact that actually failed. Completely up to us what we do, and we do that irrespective of what the application code actually is. If we were to run this, which is run 4, you can see that it first logs the entry, says command of type cscomposition.some message received at this point in time, and then it does the security check, says done the security check, and then it goes handling the message with hello. Well, that's basically it. We're doing dependency injection to the application service, if you will, i.e. some other handler. We are doing aspect orientation. We're doing all of that in the composition root, and then later on in application code, it is ignorant as to what features are under the hood. It simply does bus.handle or bus.send or whatever you call it, and it triggers whatever has been set up in the composition root. So that can lead to some very nice looking, if you're doing MVC applications, that can lead to some very nice looking controller code, very lean. In terms of testing, you would typically, where's our wrappers? You would test this wrapper only once, you'd test this wrapper only once. Similarly, you would test your some other handler only once and some handler only once, and you can be confident that they are doing what they're supposed to do. And then all that's left to do is compose these things at the very top level of your application, and you have your features ready. And well, that's pretty much all the presentation is going to cover. If you have any questions, I can well, you can type them into Jabber or Q&A, and I'll be happy to answer. Will the slides and example code be available later? Yes, they will. I'll be uploading them on GitHub probably tomorrow or the day after tomorrow, and all of that. I'll make it available through Twitter or my blog or something. Ah, that's good to know. I don't know how you did it, but I actually understand monads now. Thanks. Well, if you find that interesting, be sure to check out Haskell. It's a very nice language. Okay, cool. So if there aren't any more questions, then I guess we can call it a night. It's one of the shortest sessions of the conference. Approximately, I don't know, half an hour less than the allotted time. But I hope that's useful. And I don't know if you'll find much use for it in JavaScript, but in terms of C#, you can literally use this to get rid of most use cases of your IOC containers or aspect orientation frameworks, or any other complicated thing that requires a steep learning curve, and simply use basic C# features to kind of use aspect orientation and do dependency injection. So with that, I'll say thank you. Thanks for coming, and so thanks, and good night.